Hello, my dear students. So, in this lecture series, I am going to solve some of the interesting numerical problem from the JEE Advanced perspective. So, let us start with the solution of this problem. So, here there are two blocks. Two blocks of mass M1 and M2 are initially connected by a spring. Stiffness of the spring is given as A. Okay. So, this is the M2 part and this is the M1. This is the M1 and this is the M2. Initially, they are connected with the spring, and the coefficient of friction between the blocks and the surface is mu, that is equals to half given. So in this situation, here also mu equals to half, and here also mu is equals to half. Now this coefficient of friction is nothing but the kinetic coefficient of friction. Okay. So you are asked to calculate the minimum constant force A to be applied on M1. Here I am applying the force A on M1 in order to slide the mass M. Okay. So once I try to pull the mass M1, so gradually what happens? The spring force will increase. So initially when there is no F is applied on the M1, so I say that there is no elongation of the spring. That means there is no extension. That means the spring has no experiencing any kind of force. So once I am applying a force, now the spring will try to expand, and because of that the spring force will come into the picture. Let us say, first of all, target what is the minimum force required for the M2 to be being pulled. So if I draw the free body of M2, so for M2, let us say, in order to pull the M2, so only responsible force that can be pulled by to pull M2 is equals to spring force, that is, let us say, Kx0. So when the spring is expanded by a distance of x0, elongated by a distance of x0, then only M2 may start to move, and for that reason, so it should be equals to a friction force. Now here the friction is how much? Half times m2g. Okay. So what is the condition to move the M2 block? So Kx0 should be equals to, minimum condition is equals to half times m2g. That is the answer for this situation. Okay. Now what is x0? So x0 is the elongation of the spring at that instant. Now why the x0 comes? Because initially what I am saying that the particle is moved. Particle M1 is being pulled by the force F. So for that situation, if I want to calculate, let us say at any x location, once the particle is displaced by, let us say, spring is displaced by x distance. So for that situation, the force on the M1 is F in this direction. Okay. And here the spring force is K times x. And here the friction force is equals to how much? That is half into M1g. Okay. So net force on the block M1, F net on the block M1 can be written as F minus Kx minus M1g by 2. There is a net force acting on the particle M1. Now because of this net force, the elongation takes place, and I want to calculate what is the work done involved in the force F1, in the force A, due to the force A, for the elongation produced by the M1. Okay. So work done can be written as integration of F dx. Now what is the limit of x? X is starting from 0 to x0. Why? Because x0 is the minimum elongation required to start the block M2 to move. We have already calculated that. So once I do the integration of f dot dx within the limit 0 to x0, so what I am getting? F into dx means x0 minus k into x0 square by 2 minus m1g by 2 into x0. So that is the work done. Now that work done is basically what? That work done is giving the change in kinetic energy. That work done is giving the change in kinetic energy. So initially the what is the M2 value? M2 was initially at rest. So initial kinetic energy. So kinetic energy initial should be equal to 0 because M2 was at rest. Now you are willing to get the value of F minimum. That means the final kinetic energy is also to be 0. That means delta kinetic energy, that is 0. Okay. That means work done that I am getting is entirely equals to 0 work done. Why? Because there is no change in the kinetic energy. That will give the idea of the minimum. So if I simplify it, so x0 will cancel out. So F is equal to how much? K times x0 by 2 plus m1g by 2. That will be your answer. Now what is Kx0? Kx0 equals to m2g by 2. So if I write it, so it becomes m2g by 4 plus m1g by 2. Now in the question you are asked to calculate the F in the form of P times m1g plus Q times m2g. So P is the coefficient of m1g part. that we got as half. So this number, P number is half if we compare this, and Q number is 1 by 4. So our answer is 1 by 2 plus 1 by 4 means 3 by 4. So 3 by 4 is the answer for P plus. That is your answer. Okay. So this is the P by Q, P plus Q value. That means what you can say the F minimum. It is the F minimum number in order to start the movement of the block M2. Okay. Hope you understand this. Thanks for watching my video. If you like it, please subscribe my channel. Okay. Bye then.